All right, today we are going to work on some more equations that are quadratic functions in standard form. We're going to start out graphing them, and then we're going to look at some word problems involving quadratics. So quick review from yesterday. We have a quadratic here that is in standard form. To find the vertex, we have to do the opposite of b divided by 2a. Remember, a is the number in front of x squared, b is the number in front of x, and c is your constant. So we want the opposite of negative 4, which would be positive 4, and we're dividing by 2 times our a value, which is negative 2. So we end up with 4 divided by negative 4, or negative 1. So my vertex has an x-coordinate of negative 1, and my axis of symmetry is the equation x equals negative 1. Then to find our y value, we plugged that negative 1 back into our equation. So we have negative 2 times negative 1 squared minus 4 times negative 1 plus 1. We always square things first. So negative 1 squared is going to be positive 1 times the negative 2 in front gives us a negative 2. In the middle piece, we have negative 4 times negative 1, so positive 4. And then simplifying, negative 2 plus 4 is 2, plus another 1 is 3. So my y-coordinate is 3. And this is a parabola that has an a value that's negative, which means it should be upside down. It's been reflected over the x-axis. So that means we have a maximum up here for our vertex. And the highest we're going to get, we found y to be 3. Our domain is always all real numbers. And our range, remember, is tied to our y-coordinate maximum or minimum. In this case, our y value was 3. And because our points are going down from that height of 3, then we know that y has to be less than or equal to 3. All right, we need to find some points to graph. We found the vertex to be negative 1, 3, so we'll go ahead and plot that. Another easy point that we want you to find is the y-intercept. That's the value for y when x is 0. And if we put zeros in for all of our x's here, the only thing we're going to have left is our constant. So we have a value for y of 1. So we'll plot 0, 1. Remember, we have a line of symmetry that goes through that vertex. And we can mirror our values across that line. So we would have this point if we mirror our y-intercept. And let's go ahead and find one more point, and then we can mirror that. So our x values in our t-chart are negative 1 and 0. So let's go with the next one over, just a positive 1. So we are going to plug that into our equation, which was negative 2 times something squared minus 4 times something plus 1. And we are plugging in a positive 1 this time. 1 squared is just 1 times negative 2 is negative 2. Negative 4 times 1 is negative 4. And then combining all of that, negative 2 minus 4 would be negative 6, plus 1 would be negative 5. So let's go ahead and plot the point 1, negative 5. That is 2 spaces to the right of my line of symmetry, so we can also mirror that over 2 spaces to the left. And then we simply draw in our parabola. And thinking about the transformations, our a value was negative 2, which means it's been reflected and had a vertical stretch, which is fitting what we have here. We have an upside down parabola, and it is skinnier than our normal ones. All right, so the main focus today is on solving quadratic word problems. When a quadratic word problem references finding the maximum or minimum value of a function, it's really asking for the vertex. We've been doing that with our graphs, finding a maximum or minimum value by looking at our vertex. Our steps for solving vertex word problems. We're going to use that x equals negative b over 2a formula to find where the max occurs. That's finding where it occurs. That's finding our x value. And we want to be careful that we don't round that answer because we will be using it later to find other things. Then we can plug that x value back into our function to find our y value, which is going to be what the maximum or minimum is. Okay, so we use the x equals negative b over 2a to find x, which is typically where the maximum occurs, and then we're going to plug that value in and find the y, which tells us what the actual maximum is. If we're asked when the value will return to its starting point, think of mirroring that value over the vertex and finding double the distance. For example, if we have a parabola that looks like this, and we have a vertex here, there's my line of symmetry. So I know that it took this much time to get to the middle mark, but it is symmetric. So this amount, whatever this x is, this would be the same. So we really are just doubling it. Even if the parabola starts above the origin, we can still look at when it will be back to the same height as when it started, simply by looking at mirroring that point across the line of symmetry. So we're doubling our x value. All right, let's try a couple questions. So the first one says the height of a ball thrown upward from 5 feet with an initial velocity of 60 feet per second can be modeled by this equation, where h of t is the height in feet and t is the time in seconds. So we are given h of t, so our height is based on the time it's in the air. We have negative 16t squared. This is very common. You're going to see that negative 16 a lot. It is the gravitational constant. So that is the effect of gravity. Our initial velocity was 60, and you're going to see initial velocity always as your b term. And then your c value, remember, if time is 0, we just get whatever we had for c. So in this case, our starting height is 5. So if we just did a quick sketch, we are starting here at a 5, and our parabola is upside down, so we must be doing something like this. Okay? The ball's going up in the air, and then eventually gravity is going to pull it back down. So the first question says, when does the ball reach its maximum height? Well, when is time? And time is like our x-coordinate in our equation, all right? And y was height. So when does the ball reach its maximum height is really asking you to find the x-coordinate of your vertex. How long does it take to get to that highest point, that middle mark? All right, and we had the formula x equals the opposite of b over 2a. In this case, our b value is 60, so we want the opposite of that, negative 60. And our a value was negative 16. So we end up with negative 60 divided by negative 32. That's going to come out as a positive 1.875 seconds. So less than 2 seconds for it to reach its highest point. The second part says, what is the maximum? That is our y value. We want the height. Okay, so we found our x-coordinate to be 1.875. Now we have to figure out how high we went. So we need to plug this 1.875 into our equation. So we're going to find the height at 1.875. Don't forget your little square as part of that formula. All right, so you can pause the video, go ahead and grab a calculator. You can type it in just the way we have it, negative 16 and then parentheses 1.875 to the second power, plus 60 times 1.875 plus 5. When you have your answer, go ahead and turn the video back on. All right, so your height here, your maximum height should have been 61.25 feet. Then the third part says, when will the ball be 5 feet from hitting the ground? So we are really looking for it to return to that same level that it started at. We started at 5 feet. We want to know how long it takes for us to get back to that same height. Because of the symmetry of our graph, if we know this is 1.875, then we also know this much is 1.875. So to find this answer, we really just have to take 2 times our 1.875. And we get 3.75 seconds. So that seems logical. It was a little under 2 seconds to get to the halfway mark. It's going to be a little under 4 seconds to get to the other side of that. All right, our next example says the height of a ball thrown upward from 7 feet with an initial velocity of 50 feet per second can be modeled by this equation. H of t equals negative 16t squared plus 50t plus 7. So again, this is gravity, the effect of gravity. This is our initial velocity, and this is our starting height. All right, so the question asks, when does the ball reach its maximum height? So once again, we are looking at starting here at 7 feet. The ball is going to go up in the air. Gravity will pull it back down. When is our time? And our x-coordinate is time. Our y-coordinate is height. So when does it reach its maximum height is asking us to figure out how far over do we have to go to get to that middle mark. So we do x, or in this case t, I guess we could write. Our time equals the opposite of b, so negative 50, divided by 2 times a, negative 16. So negative 50 divided by negative 32, and we should get 1.5625 seconds. Again, we don't want to round that answer right now because we are going to need it in the next question. Now it's asking what is the maximum height. Now they're looking for our height, or our y value. So we are going to plug in that 1.5625 into our equation for time. So negative 16 times our time squared plus 50 times the time plus 7. Once again, go ahead and grab your calculators, pause the video, and punch that into your calculators. All right, we should end up with a height of 46.0625 feet. The third question says, when will the ball be 7 feet from hitting the ground? So again, we're looking for when it's back to the same level that it started at. And because of our symmetry, if we know this is 1.5625 seconds, then this is also the same time. So the time it takes to get back to the same height that it started at is just double our x-coordinate of our vertex. So 2 times that, we get 3.125 seconds. Okay? So again, when does the ball reach its maximum height? We are looking for how long it takes to get halfway across, right, to that line of symmetry. And then what is the maximum height is asking us to plug in that x value or that t value and find our height. All right, an economics example. It says a model for a company's revenue, which is how much it makes selling stuff. So a model for a company's revenue from selling a software package is R equals negative 2.5p squared plus 500p, where p is the price in dollars of the software. What price will maximize revenue, and then what is the maximum revenue? So if we consider this kind of like our y and our x, okay, then that means for my graph, my x-coordinate really represents the price, and my y-coordinate represents the revenue. Okay? So the first question says, what price, so what x value, or in this case p, they used p for price, what price will give us the maximum revenue? Well, my highest revenue is going to be at the vertex. Since my parabola has a negative a value, we know that it's going to be upside down, and we're looking for this point. So we need to find our vertex. We need to find our price and then how much revenue we make. So to find our price, we do negative b over 2a, or the opposite of b over 2a. In this case, b is 500, and a is negative 2.5. Well, 500 ends up getting divided. 2 times negative 2.5 is negative 5. So we have, opposite of b. We need negative 500. There we go. Negative 500 divided by negative 5, and we get 100. So the best price that I can use to maximize my revenue would be $100. To find out what that revenue will be, I have to plug in 100 for my price. All right, so negative 2.5 times 100 squared plus 500 times 100. Punching that into our calculators, we should end up with $25,000. So we should sell the software for $100 each, and our max revenue will be $25,000. All right. Our last example is a physics example. It says the equation for the motion of a projectile fired straight up at an initial velocity of 64 feet per second is h of t equals negative 16t squared plus 64t, where h is the height in feet and t is the time in seconds. Find the time, so find x in this case, find the time the projectile needs to reach its highest point, and how high will it go. Once again, gravity is going to cause that projectile to go up and come back down. All right, our c value in the last question and in this question is 0, so we are starting here at the origin. Going up, we'll hit a high point and then come back down to the ground. So we want to find how long it takes to get to that highest point. So we're going to find our t value, opposite of b over 2a. In this case, b is 64. We want its opposite. 2 times our a value. So we have negative 64 divided by negative 32, which is exactly 2. So it will take exactly 2 seconds to reach its highest point. What that highest point is, we need to plug our 2 value into that equation to find that. So we have negative 16 times 2 squared plus 64 times 2, and we get a height of 64 feet. So we take 2 seconds for it to get to its highest point, which is 64. All right, you will be practicing these with a worksheet. For those of you who are working at home, there will also be a couple questions in Delta Math for you to try.